I'm going to go through two methods of finding the common difference. We've gone through finding the nth term, finding the first term, but what if you're missing the common difference? So in this case, I'm going to go through two examples. In this example, it's quite a straightforward one where you're just missing where you have the first term and you're missing everything else. So when you have the first term and you have an extra piece of information about the sequence, then you can just use the formula, the nth term formula. And you're just going to substitute u1 here, so that's 6. And you're going to substitute the other piece of information that you have, which is that U12 is 94. Now, it could have been anything else. Maybe they gave you U24 equals to something. And you could use this piece of information as well. But at the moment, we only have this U12. So any other term in the sequence would be correct. So we know that U12 here is 94. And it's in the 12th position. Okay, so remember that your UN and N have to match. So this is the actual term, and this is the position of the term. So the actual term is 94, and its position is 12. And you just solve it for D now. So it's quite straightforward. You have 94 equals to 6 plus 12 minus 1, that's 11, so 11D. And so you have 94 minus 6 equals 11D. And so you have 88 equals 11D. And so D is equal to 8. And you can check your answer by substituting back in. You can go 6 plus 8. Could go 6 plus 12 minus 1. And then the common difference is 8. So that's 6 plus 11 times 8, which is 88, and that will give you 94. So correct. So make sure you check your answers right after every question. So that's a straightforward one when you have the first term. When you don't have the first term, it gets a bit challenging because you can't just immediately use the formula. So I'm going to teach this using two techniques. One is a more straightforward technique, and the other one is more algebra, so we're going to be doing simultaneous equations. So for this question, you have the second term of an arithmetic sequence is 1, and the seventh term is 26. So if I summarize this information, so I could write U2 is 1, and U7 is 26. So I have this information. Not sure what to do with it. If I use the formula, then I'm left with two unknowns. I don't know the first term, which means I won't be able to solve it like the previous question. But if I lay it out, I know U1 is somewhere here. Then I have 1 as U2, U3, U4, and so on until I get to U7, which is 26. 26 here. And there's a specific number that I've been adding from 1 until I got to 26. So there's a specific number, the common difference, that I've been adding consistently until I got to 26. So if I translate this, let's just figure out how many times. So how many times did I add this number? Well, I'm starting from U2 and I'm ending at U7. So I've been adding this number 7 minus 2, so 5 times. So this D is repeated 5 times. 1, 2, 3, 4, and say 5. Okay. U4, U5, U6, and this would be U7. The reason I've put a dot here initially is just to show you this method. Because just in case it's a really big sequence, say I have U50, it won't make sense for you to lay them all out. So to know how many times you've added this common difference, you just take the highest term you have minus the lowest term. So 7th position minus 2nd position, and you get 5, which means you've added the common difference 5 times. Now, how do I translate this? Well, you start with 1, and you've added this common difference 5 times. So I've added the common difference 5 times, and that should give me 26. And there you go. You have an equation now in terms of the common difference, and we can solve it. So we have 5d is equal to 26 minus 1, which is 25, and then d is equal to 25 over 5, which is 5. And you can check your answer by using the formula now. So substitute in the formula, see, the formula won't work actually because you don't have u1, but just test it out. Try adding 5 times and see if you get from 1 to 26. But to actually use the formula, so now I'm going to go through the longer method, is to use simultaneous equations, which maybe would make sense for some people. So you think, well, now I'm stuck. I don't know what to do. But I know that u2 is equal to u1 plus n minus 1, which in this case is 2 minus 1, times the difference. If I simplify this, I'm going to get u1, 2 minus 1 is just 1, so u1 plus d. And u7 is u1 plus, well, it's 7 minus 1, so 7 minus 1d. And if I simplify this, I'm getting u1 plus 6d. So you have two equations, simultaneous equations. If I substitute the values I know for u2, so I know that u2 is 1. It's equal to u1 plus d. And I know that u7 is 26. So I'm going to 26 is equal to u1 plus 6d. Okay, so just imagine this is a simultaneous equation. You have x and y here, x and y, and you can solve it now. So I'm going to actually swap them around. We're going to take this to the bottom. That there, so it's just going to make it easier to subtract. We're going to subtract to cancel out the u1, so this would always work. So 26 minus 1 is 5, u1 minus u1 is 0, 6d minus d is 5d, and as you notice, we are in this position now, and we get d is equal to, 25, not 5. 25, so we get 25 divided by 5, which is 5. So we get the same answer. So you could use simultaneous equations in any situation. Just because it's arithmetic sequences, your u1s will always cancel. You'd use this method if you also need to find u1, which is what we're going to do in another video. So if I substitute 5 now in here, I'm going to be able to find u1, just like you do with any simultaneous equation. So hopefully this method was clear. You have enough methods to use, and now hopefully they made sense. You can use this method for any difference you have, and the most important thing is to translate what you understand into an algebraic form and check your answers later on.